In this video, we try to understand why it is wrong to select delta equal epsilon in certain delta epsilon proofs of limits. So let's look at the limit definition, the common limit definition. So we write the limit when x goes to a fx equal L if and only if we can prove that for all epsilon there is a delta positive such that x minus a less than delta and less than 0 implies fx minus L less than epsilon. So this is what we normally call the common definition, common epsilon delta definition that we use to prove a limit exists. But the problem is this definition is not exactly correct. So we're going to see why this is not correct. So let's try to consider this problem. So consider, so we try to prove that, so let's say consider the problem of, let's say we try to prove the limit when x goes to 4, the square root x equal to, and this we know because the reason is the square root function is continuous, so we can plug in the value, so it works. So that's true. So in this problem you can see that the fx equal the square root function. So that is defined for x greater than or equal 0. Actually, that's the problem. That's where the problem comes. So that means if we have a function which has a discontinuity at any point other than a, we cannot choose delta equal epsilon. It's going to create a problem. So that's how we're trying to understand. So let's look at the argument. So so we write. So I'm going to work with the rough work. So because for these problems you always have to do a rough work and figure out what is the actual delta. So I'm going to do the rough work. So let's say for given epsilon, for given epsilon positive, what we need to prove is square root x, that's a function, minus 2, that's the limit we get, less than epsilon. That's what we need to prove, we need to end up. But we know that, so this is implied by this one. So you can say, so this is like a if and only if statement. So if this is true, then this is also true. What we can do is we can multiply by the conjugate. That's what we normally do for square root functions. So we're going to multiply by the conjugate, top and bottom. And then you can see that this is so this is if and only if. So that means if one implies the other. Now, you can simplify the top. So this again, if and only if. So the top simplifies to x minus 4, so that's exactly what we are waiting for. The bottom is positive, so we can remove the absolute sign, so we can write it like that. So this is less than epsilon. Now what we're going to do, so after that it's going to be only one direction. So that one is implied by, what we're going to do, we're going to pick the largest value of this function. Because if you pick the largest value of this function, then this is gonna imply, because you can see that, so the observation is square root has to be greater than or equal 0. So that means if you pick the largest value, and the implication gonna be that way, so you can see that the largest value is absolute value, absolute of x minus 4. So the largest value of that function 1 over square root x is 1/2, because you can see that since the square root x is greater than or equal to 0, if you add something positive, it's going to be smaller because we are adding something to the denominator. So this is true, and the implication go that way. And again, we can write that, so there's implication again to this direction. So you can see that instead of 1/2, I can say 1, because then the implication go that way. Because if you say 1, the 1/2 is definitely smaller than that. So that means the implication goes that way. So the last two only going the left side, the top, if and only if. So this says that you have an option to select epsilon equal delta. because you can see that this is exactly what we need. So the problem is actually this is wrong. You cannot do that. So let's see why this is wrong. What we normally do is in a regular form, because I have seen that like everywhere. Sometimes like we say, so I'm going to write in red. It looks like we may choose delta equal epsilon, but this is not true. So let's see why. So let's look at the actual function now. And also in theory, you can pick any smaller epsilon. So for example, you can say delta equal epsilon half. Okay. So in theory, like you may pick any smaller. You may pick any smaller epsilon. So like for example, epsilon half. That also works in the regular theory, but that's what we think. But all of them are wrong. So let's look at the reason now. So I'm going to look at the graph. So this is the graph of this curved function. So it's going to go like this, and it's an inclusive function. So this is the value we pick. So we're going to evaluate at 4. So that means the value is 2, because it's a continuous function. You can just plug in the value. Now the problem. So because we know that by the definition, this should be true for any epsilon that we pick. So it doesn't matter, because it's true for all epsilon. Because the theory says that for all epsilon, there is a corresponding delta, which is a function of epsilon. So that's why it's such that, so this is true. If this is true, so in this case 4 is true, then the other side is square root x minus 2 has to be less than epsilon. So say if the first one is true, then this should be. But we see the problem. Now what I'm going to do, I will pick, because it has to be true for all epsilon, let's pick epsilon equals 6. So I'm going to say, okay, so let epsilon, which is exactly equal to delta, equals 6, and we can see that this is true, this is positive. Now what does that mean? This means if you look at this condition, so this says that this is less than delta, delta, which is 6. So this simply says that if you write in the expanded form, so this is the number line. So we have number 4, we don't need that because it's greater than, and then we're going to go 6 units away from that. So this is 4 plus 6, so which is 10, and then we have to go to the other side, which is 4 minus 6, which is negative 2. So that means what it says that if you pick any x here, then it should satisfy the condition, and we can see that it looks like. So what I'm going to do, I'm going to pick a value. For example, let's say I'm going to pick x1 equal negative 1, because negative 1 is in this interval. So if we x equal negative 1, what will happen? So you can see it is, the interval is going from negative 2 to 10. So I pick the value here. So that's the value I'm going to pick, x1 equal negative 1. And then you can see that for this value, the implication, there are two sides, the first side and the second side, and you can see the first side is true. So you can see if you pick x1 equal negative 1, and you can see that, so this is true. So 0 less than x1, which is 1, and which is actually negative 1. So you can see negative 1 minus 4, and then so this is actually less than 6, because you're going to see that this is equal to 5. So this is true. So this side is true. But what happened to the other side? You can see the other side, you're going to get, for this value, negative 1 square root minus 2 less than epsilon, which is equal to 6. Is this the case? And you can see that this is wrong. The problem is this is not even defined. So you can see that it's not defined. So that means this side is false. So you can see the left hand side is true, but the right hand side is false. So that means this implication does not work anymore. So that means this proof is completely wrong after that. So now what's the problem here? So you can see that we cannot pick epsilon delta equal epsilon when there is a discontinuity, because according to the proof, epsilon can be anything. So if you pick a large epsilon, this always falls. So if there's a discontinuity at any other point other than a, then we cannot pick delta equal epsilon. So that means the correct proof has to be, and that's what I'm always using. So like this, you need to consider the domain. So the correct definition has to be, we can say limit x goes to a, fx equal L means, or if and only if, means for all epsilon there is a delta positive such that for all x in the domain of the function, we have to add that part. Then the rest is true. So x minus a less than delta implies fx minus L less than epsilon. In this case, yes, you can pick delta equal epsilon even for this problem, because we have that extra condition there. So that means only for the values which is in the domain. So that means that does not create a problem now, because that value is not in the domain. So we don't worry about what's going to happen there, because it's not true for that part. So if you start with a false, then so you know that in logics, so this statement is true because this starting one is always false. So that means your definition has to be like that, otherwise the argument is completely wrong. Okay, so thank you.